In 2024, China is putting millions of tons of concrete back into use every single year. That's not a modest figure. It's a massive, staggering quantity of material that would have simply been buried in enormous pits just a few decades back. Picture a building that took years to plan and construct. Now picture it flattened in mere hours. For the longest stretch of time, whenever a structure came down, all that heavy debris got treated as worthless garbage. It got loaded onto trucks, hauled out to sprawling pits beyond the city limits, and dumped there permanently. Entire mountains of shattered concrete just accumulated, consuming space and generating serious problems. But something shifted. Someone glanced at a heap of broken rock and saw something entirely different. They didn't see garbage. They saw a hidden resource waiting to be put back to work. Today, aging buildings throughout China aren't simply demolished. They're methodically dismantled through an organized process that transforms yesterday's structures into tomorrow's roads, walkways, and foundations. In a nation where entire cities are being modernized at breakneck speed, this system is reshaping how major cities grow and evolve. If you're enjoying videos like this, please tap that like button, since these take considerable effort to produce, and subscribe so you don't miss what's next. What you're about to hear is a real account of how an entire engineering discipline transformed itself completely. It involves colossal machines, powerful magnets, and a fresh perspective on what we consider disposable. But to understand how millions of tons of dense, unyielding concrete found their way back onto construction sites throughout China, you first need to understand why the old approach had to be abandoned in the first place. Think about what happens once a child finishes constructing a tower out of building blocks. When playtime wraps up, the tower gets knocked over, and every single block goes right back into the container for the next round. Nobody tosses the blocks into the garbage. For a remarkably long stretch of time, the adult world of construction did precisely the opposite. Once a building aged out, it got smashed apart, and the fragments simply got discarded. In a country like China, where cities are modernizing at an extraordinary pace, this habit created a problem nearly too large to visualize properly. Entire neighborhoods are undergoing renewal. Aging overpasses are being swapped out for larger, safer replacements. Deteriorating factories are being cleared to make room for fresh developments. Bridges that carried traffic for 4 decades are being redesigned to accommodate heavier loads and denser traffic. All of this activity means mountains of solid concrete are coming down every single year. We're not discussing a few hundred tons scattered here and there. We're discussing millions of tons of dense, fractured material that needs somewhere to go. For a long stretch, the standard approach involved loading all that broken material onto a fleet of trucks and hauling it far from the city center. The trucks would queue for kilometers, burning fuel while waiting to dump their heavy loads into enormous landfills. Picture a backup of dump trucks stretching along a highway, each hauling 20 or 30 tons of shattered concrete, all headed toward the identical massive pit. This generated 2 significant headaches. First, transporting all that dense rock proved incredibly costly. Consider how much fuel a massive truck burns while hauling tons of concrete across an entire city. Then multiply that across thousands of trips occurring weekly. The expense was staggering. The second headache involved space itself. Those disposal sites kept expanding, consuming land that could otherwise become parks, farmland, or new housing developments. Picture a pit the size of several football fields, growing deeper and wider month after month, packed entirely with gray rubble. While these mountains of broken concrete sat there accumulating, the construction sector faced another problem brewing on the opposite side of the equation. They required enormous quantities of fresh stone to build the emerging city. Producing concrete from raw materials means extracting stone, gravel, and sand from quarries. These quarries frequently sit far removed from the city, sometimes hundreds of kilometers away in rural territory. getting fresh rock out of the ground and transported into the city required yet another fleet of trucks, burning additional fuel and inflicting further wear on the roadways. It amounted to a truly frustrating cycle. On one side of the city, people paid to discard perfectly usable rock. On the opposite side, people paid to extract entirely new rock. The city was literally throwing away the exact material it was simultaneously paying to mine elsewhere. Engineers and urban planners eventually examined the underlying numbers and recognized a substantial opportunity sitting right in front of them. They didn't actually have a garbage problem. They had a supply chain problem that could be fixed. The fragmented remains of old buildings weren't trash at all. They were precisely the raw material needed for the next wave of construction. This straightforward shift in perspective completely rewrote the playbook. Rather than strategizing how to dispose of things, the industry started strategizing how to capture and reuse every single fragment. But turning that concept into reality required an entirely different method of taking buildings down in the first place. If you intend to reuse the components of a building, you can't simply pulverize it into dust using a giant wrecking ball. That older method of demolition blends everything together into one chaotic mess. You end up with concrete tangled together with wood, glass, plastic, and metal, making later separation nearly impossible. It would resemble tossing every dinner ingredient into one single pot, then attempting to separate the salt from the pepper after everything's already been cooked together. Building a real recycling system meant the demolition process itself had to become deliberate and careful. Throughout China today, a building's final chapter begins with a methodical, organized procedure called deconstruction. Long before any heavy machinery arrives on site, teams of workers enter the aging structure to strip it down piece by piece. It resembles disassembling a giant three-dimensional puzzle. They begin by carefully removing doors and windows, so the glass and frames can be reused or recycled independently. Then they trace out the electrical wiring and cut it free. This wiring contains valuable copper that gets sold and melted down into fresh wiring elsewhere. Next, they disconnect the plumbing infrastructure, extracting metal and plastic piping that follows its own separate recycling pathway. Even interior light fixtures and HVAC units get unbolted and hauled away. They remove bathroom sinks, kitchen tiles, and ceiling panels. Anything capable of a second life somewhere else gets extracted first. This particular step proves absolutely essential. By clearing out the building's interior beforehand, workers ensure that once the concrete finally comes down, it remains as pure as achievable. That purity makes the subsequent recycling stages considerably easier and more efficient. Only once the structure is stripped down entirely to its bare bones do the heavy machines finally roll in. But these aren't ordinary demolition machines. They're massive excavators fitted with powerful hydraulic shears and specialized crushing attachments. Picture an enormous pair of scissors mounted on the end of a 50-ton machine. These shears can slice straight through thick steel beams and bite clean through chunks of reinforced concrete. The machines operate systematically, dismantling the building floor by floor, starting from the top and progressively working downward. Within just a few hours, a structure that stood tall for decades gets reduced to a massive pile of broken chunks scattered across the ground. It's a dramatic, forceful sight to witness. But within this new system, that demolition represents merely the opening step of a highly coordinated journey. Every single truck arriving at the site already knows precisely where it's headed next. The rubble isn't destined for a landfill. It's heading toward a specialized facility designed specifically to transform heavy chunks of concrete into something entirely new. The real transformation happens once those trucks arrive at the recycling facility itself. When a truck loaded with broken concrete pulls into a modern recycling plant, it resembles a massive pile of useless gray rock to an untrained observer. It just looks like dust and jagged fragments. But the people operating these facilities perceive something entirely different. They see a collection of valuable raw ingredients, simply waiting to be processed. It's comparable to a baker examining a sack of flour and envisioning 100 finished loaves of bread. The first machine the concrete encounters is a massive industrial crusher. These crushers are enormous, deafening, and remarkably powerful. Giant steel jaws open and close repeatedly, gripping blocks of concrete weighing hundreds of pounds and smashing them into considerably smaller fragments. The noise inside the facility is overwhelming, and dust fills the air constantly, even with the massive water sprays deployed to suppress it. The machines run almost continuously, chewing through loads of rubble throughout the entire day. Structures that required years to construct get broken down into tiny fragments within mere minutes. But crushing the concrete isn't actually the end goal. It's merely the starting point. The crushed fragments fall onto a lengthy series of conveyor belts, winding throughout the facility. As these fragments travel along the belts, they pass through a sophisticated sorting process. The first thing the belts encounter is a row of massive, powerful magnets. These magnets hang suspended directly above the moving concrete. They perform a critical function. Most concrete structures are reinforced internally with thick steel bars called rebar. When the crusher pulverizes the concrete, considerable amounts of that steel end up mixed throughout the fragments. The magnets automatically extract the steel from the pile as it passes underneath. The steel clings to the magnet, gets carried away, and drops into a separate collection bin. This steel doesn't go to waste whatsoever. It gets sold directly to steel mills, where it's melted down and transformed into brand new steel for future construction projects. Meanwhile, the concrete fragments continue traveling along the belt until they encounter vibrating screens. These screens function essentially like giant kitchen sifters. They shake back and forth continuously, sorting concrete pieces according to size. If a particular fragment remains too large to be useful, the screen redirects it back toward the crusher for another round of pulverizing. Fragments matching the ideal size fall through the openings and continue onward to the next stage. Some facilities even deploy specialized air blowers to eject lightweight scraps of wood or plastic that might have slipped through the earlier sorting stages. What began as a heap of junk is starting to resemble clean, properly sorted building material. But an important question still lingers. Can you actually trust this old, pulverized concrete to support something newly constructed? The answer is affirmative, but engineers never simply guess at this. Before this recycled material gets deployed for anything, it must pass a rigorous series of tests inside specialized laboratories. Scientists collect samples of the crushed concrete and precisely measure its strength characteristics. They test how much weight it can bear and how it responds under pressure. They also measure the exact dimensions of the fragments and verify there's no leftover dust or debris that might cause complications later. They even evaluate how effectively the material drains water, which matters considerably for road construction applications. This testing process is precisely what keeps the entire system safe and reliable. The results inform engineers exactly what type of job this specific batch of recycled concrete is suited for. The cleverest aspect of this entire system is that old concrete doesn't need to return to performing the identical role it previously served. An aging skyscraper doesn't have to become a new skyscraper. The material instead gets matched to whatever new application suits it best. This is where the system becomes truly inventive. For instance, when builders construct a new highway, they require a deep, solid foundation layer of crushed stone underneath the smooth asphalt surface. Recycled concrete proves absolutely ideal for this particular purpose. It's dense, it compacts tightly, and it allows rainwater to drain through properly so the roadway doesn't flood during storms. Rather than excavating fresh stone from some distant mountain quarry, highway builders can simply utilize this crushed, recycled concrete instead. It also gets used constructing foundations for city streets and sidewalks throughout urban areas. When a new neighborhood requires a drainage system to channel rainwater away safely, crushed concrete makes excellent filler material for those underground trenches. It can even get compressed into heavy blocks, used constructing retaining walls that hold back soil along hillsides. In certain cases, the cleanest and strongest recycled fragments get blended directly into brand new concrete mixtures for building components that don't require exceptional strength. Think of it like a relay race passing a baton forward. The old building hands off its material to the next construction project, and this cycle continues indefinitely. By repurposing old concrete for these specific applications, builders throughout China are saving enormous sums of money. They avoid paying to excavate fresh rock from distant quarries. They avoid paying to transport new rock across considerable distances. The material they actually need is already sitting right there within the city, ready for immediate use. It's a practical loop where almost nothing gets wasted throughout the entire process. But this intelligent approach to construction extends well beyond simply saving money on raw rock materials. It would be simple to look at this entire process and just label it recycling. But that particular word doesn't fully capture the true scale of what's actually happening here. The underlying goal was never merely to recycle a handful of bottles and cans for environmental goodwill. The real objective is ensuring absolutely nothing goes to waste whatsoever, because within a rapidly expanding nation, waste ultimately translates into lost money and lost time. This entire process has fundamentally transformed how China's construction industry approaches its work. For a remarkably long stretch, building anything followed a straightforward, linear progression involving 3 steps. First, you extract fresh stone and sand directly from nature. Second, you utilize that material to construct a structure. Third, once that structure ages out, you discard it entirely and start completely over. It formed a straight line that consistently terminated in an enormous pile of garbage. But now that straight line has been curved into a circle instead. China is demonstrating that a 4th step exists. Rather than discarding materials, the old components get revitalized and assigned an entirely new purpose. Aging bridges and buildings are no longer viewed as lifeless junk. They're viewed instead as a substantial supply of building materials, patiently awaiting their next assignment. This isn't merely a pleasant environmental gesture either. It represents a brilliant strategic decision. China continues building new cities and expanding existing ones at extraordinary velocity. Sustaining that pace requires a constant, massive supply of building materials. Reusing millions of tons of concrete annually means they don't need to rely as heavily on distant quarries anymore. It reduces the expense of transporting heavy materials across long distances, because the recycled concrete already sits precisely where it's needed. It also accelerates overall construction timelines significantly. Within a rapidly growing city, every month of delay costs builders substantial amounts of money. If builders must wait 3 weeks for a trainload of fresh rock arriving from some distant mountain, the entire project slows considerably. But if there's a recycling facility just 10 minutes away producing crushed concrete daily, builders never experience that waiting period whatsoever. The construction industry becomes faster, more affordable, and considerably more resilient overall. Rather than depending on a constant, steady stream of new materials arriving from far away, cities can supply a substantial portion of their own needs directly from buildings they've already demolished. It renders the entire city considerably more self-sufficient overall. It also means fewer trucks clogging up highways between the city and distant quarries, translating into reduced pollution and lighter traffic congestion. There's also a clever economic ripple effect worth noting. The recycling facilities themselves generate new employment opportunities and entirely new business ventures. People are needed to operate the crushers, maintain the magnets, drive the trucks, and conduct laboratory testing on the material. An entirely fresh industry has emerged around something that used to simply get discarded as garbage. Perhaps the most remarkable dimension of this entire story involves contemplating what's currently being constructed throughout China right now. The great buildings and roadways of tomorrow will quite literally contain fragments of the past embedded within them. A building demolished today could end up supporting the tires of a car traveling along a brand new highway tomorrow. An aging concrete bridge that carried traffic for 4 decades can get crushed down and transformed into the sidewalk lining a completely new street. The dense concrete that once supported a factory roof 50 years ago might now lie buried deep beneath a brand new city park. When you walk across a freshly paved sidewalk somewhere in a Chinese city, there's a real possibility that the solid material beneath your footsteps once supported the walls of an entirely different building, located somewhere else entirely. It's an endlessly repeating cycle, transforming what everyone once considered garbage into something valuable again and again without pause. The most valuable building material of the future might not be something we excavate fresh from the ground at all. It might instead be something we've already constructed with once before. This represents one of the most significant shifts occurring within modern engineering, and it's unfolding right now, one truckload at a time. Within a world where cities continue expanding year after year, discovering intelligent construction methods represents the only viable path forward. The older model of extracting, building, and discarding is steadily being replaced by a model centered on extracting, building, and reusing indefinitely. Every time a building comes down, it no longer represents an ending point. It's merely the beginning of an entirely new project instead. Every pile of shattered concrete no longer represents a problem requiring burial. It represents a solution simply waiting to be processed properly. The concrete that constructed yesterday's China is now actively constructing tomorrow's China, and this cycle shows no signs of decelerating anytime soon. As additional cities adopt this particular system and more recycling facilities open their doors, the loop tightens further, and the waste diminishes accordingly. The industry that once generated mountains of garbage is now generating mountains of real opportunity instead. It's ultimately a story about creative thinking, powerful machinery, and the realization that the finest resources available for the future might already exist right within our own cities. If you enjoyed learning how this massive industry actually operates, leave a like and subscribe. Every week we bring you remarkable technologies, processes, and engineering projects reshaping the world that relatively few people know anything about. Turn on notifications so you never miss what comes next. There are related videos displayed on your screen right now if you'd like to keep watching further. So here's a question worth considering. If you were constructing an entirely new city, what would you build out of the old structures you had to tear down first? Let me know your thoughts in the comments below.